Hey, you are given with adjacency metric. Can you find number of provinces with that? This question is all about that only. Let's go and solve this question. Okay. So the question topic is number of provinces. Now, what question says? There are n cities. Some of them are connected, while some are not. If a city A is connected directly with city B and city B is directly connected with city C, then a city A is connected indirectly with city C. Got it? Now, a provinces is a group of directly or indirectly connected city and no other city outside of the group. Got it? You are given an matrix of n cross n, okay, is connected where is connected of I, j is equal to 1 if the ith city and jth city are directly connected, and it will be 0 otherwise. Okay, return the total number of provinces. Got it? That's the question. Let me explain you in terms of graph. Means you can see the first example right here. There are three cities, 1, 2 and 3. If you see, 1 is connected to 2, 2 is connected to 1, but 1 and 2 are not connected to 3. What does it mean? It means that 1 and 2 are one province and 3 is another province. Means there are two connected component. That's why answer is 2. Okay, if you see here, no one is connected with other city. It means there are three provinces and each are independent, right? That we need to find. So how we can do that, right? So let's see some example and then we'll be solving. Okay, so what if there is a graph like this? Means let's say you have uh, four cities. Okay, one, two, three, and four. Let's say 2 and 4 are connected and 4 and 3 are connected. Then what will be the graph? How graph will be represented? 1, 2, 3, 4, 0, 1, 2, 3. Right? Now, can we just rename it like this? Let it be 0, this be 1, this be 2, and this be 3. Right? It will be easy to represent now. If you see 0 is connected to 0, but not any other provinces. Now, 1 is connected to 3, right? But not with other provinces. But 1 will always be connected with 1. So this will be 1. Okay, what next? 2 is connected to 2 and 2 is connected to 3, right? Now, what is for 3? 3 is connected to 1 and 2 as well. Means not connected to 0, it connected to 1, it connected to 2, it connected to itself, right? Means that is input. Now, what to do? We need to traverse this graph in a such a way that we need to find number of components, right? How we can find that component? Let's say we start DFS from this point, then it will be reaching itself only and we'll able to know that this is one separate province, right? Now what next we can do? We can start with 1. If we start with 1, it is connected to 3, right? So 3 is a part of it. Now what are the cities which are connected to 3? 2. Means all these 3 will be connected because 1 is connected to 3, 3 is connected to 2. It means 1 is indirectly connected to 2, right? Means these 3 nodes are part of one provinces. So what you need to do? You need to just call a DFS algorithm. From where? From each node you need to call the DFS algorithm, right? From 0, from 1, from 3, from 2. If that particular node is already visited, it means that is part of another province which we explored previously. If not, then it will be part of the new province. That's it, right? Now, how we can do that? We need to take one visited array, right? Now visited of 0, 1, 2, 3. Initially it will be false, right? All will be false. Now, when you are at 0, what you can do? You can start from 0, and when you go to 0, you can mark that 0 as visited. Now, what you need to check? What are the adjacent value of 0? Means what are the adjacent cities of 0? If you come here and start exploring the adjacent value of zeros, then that will be 0 only. Means if you see 0 is visited or not, 0 is already visited. It means we don't have any other provinces to explore, means any other city to explore for provinces starting with 0. It means 0 will contribute to a separate province. Let's count it as 1. Okay, means initially count will be 0. When we explored this one, we count increases count. Now what next to do? You need to go to next city and check if that is visited or not. it is not visited, right? So you can mark this as visited. What next? You need to go to its adjacent. How you'll go? You need to explore this complete row, right? So if you see it is connected to 0, no, you don't have to explore that out. It is connected to 1, yes. So if you check 1 is visited, it is already visited, it means you don't have to again explore it. Now what next? You need to check for 2. Is it connected to 2? No, you are not going to explore it. What next? Is it connected to 3? Yes. So you'll be going to node 3, first marking 3 as visited, right? And then what you'll be going to do? You'll be exploring 3, means adjacent values of 3. 0 is connected to 3? No. 1 is connected to 3? Yes, right? It is connected to 3. But if you see 1 is already visited, means you don't have to explore that city again, right? So no need to do anything, right? What next? You need to come to explore adjacent city, that is 2, right? The second city. So if you see 2 is not visited, right? 2 is not visited and it is adjacent to 3, means we can go to 2 from 3. So what we need to do? We need to mark that particular node. Coming here, marking that node is visited, and then what? We need to we need to check for what are the adjacent element of 2. If we check adjacent of 2, means till this point we have explored. Now we are going in depth, and then while returning we'll process further for 3, right? For 3. Now right now we are going to explore 2. It is adjacent to 0? No. Adjacent to 1? No. Adjacent to 2? 2 is already visited, that is also done. Now 2 is adjacent to 3. Is 3 already visited? Already visited, means we are able to complete this 2 completely. Coming back to 3, from here we need to again check is 3 is connected to 3, and 3 is already visited, right? So you don't have to do anything, means 3 is also completed. What next you need to do? You need to come to 1. Now in 1 you explore this, means all are completed, means 1 is also done, right? Now after completing this, you can mark that this is the second component which we actually explored. So right now we have two component. Now what to do? You need to check for the this index, that is 2, right? Means we first explored for 0, explored for 1, now we are going to explore for 2. But if you see 2 is already visited, it means 2 is a part of any previously encountered province, right? Now next, 2 is already covered, you don't have to do anything. Let's do for 3, right? What to do for 3? If you see 3 is visited or not, 3 is also visited, it means that 3 is also part of another province, right? So here, from here you have explored all the node, and now what you need to return? You need to return the count, that is 2, right? Means in our problem we are able to encounter just 2 provinces, and that is correct, right? The same logic we just have to implement. That's it. That's all about this question. If we talk about time complexity and all, let's first code it, and then we'll analyze what will be the time complexity and what will be the space complexity for it. All good? Okay. Let me keep my iPad aside. Now go to code. Okay. So here what is given? We are given adjacency matrix. This matrix is already given, right? If you see, this matrix is given. What we need to do? We need to first write a for loop that will be checking for each provinces, and we need a visited array, right? So what we need visited array of what? Boolean value false. F, false, right? How many what will be the size of it? That will be n. What will be n? N is equal to number of nodes, right? That is length of is connected graph, right? Means 3 cross 3, then 3 will be number of nodes, that is n. What you need next is visited array. Now you have visited array. What you need to do? You need to run a for loop for each of the node, right? Means let's say for node in range, at what range? That is n, from 0 to n, right? And if that node is already visited, let's say if viz of node, sorry, not mode, it's node. Okay, viz of node is true, means that is already visited, then you don't have to do anything, means you need to continue exploring, right? And if you are going to explore some new provinces, then you need to store count of it. means you'll be storing count plus equal to 1, because from now you'll be exploring a new provinces, right? And what you need to do here, you need to call one function, that is, let's say, DFS function, and you need to pass node number. From that you need to explore, right? Till this point we have to do what else? If that is done, go for next. Okay, at the end, return count. That we need to do. Now we need to implement DFS function, right? Def DFS. In DFS, what we need to pass? We need to pass node, right? Yes, we need to pass node. What next? What else? What else we need to do? In DFS, if that node is not visited, let's say, then what we need to do first? Viz of that node is equal to true. That is first thing, right? Now for each neighbor, right? I can say each adjacent value of what? For each value of, for ADJ node actually, adjacent adjacent node of what? Means, let's say we have a node, then what we'll be getting? We'll be getting one row, and one row we need to explore, right? Node is connected and we pass node, then till its length we need to run in range of this, right? Is connected of node, and we need to take care of length. Sorry, yeah, length. And then from here we need to run if adjacent node, if is of adjacent node is false, right? And that is connected of node and adjacent node is 1, right? It's integer array, so is equal to 1. Then we are going to call DFS again with adjacent node number, right? What else? I guess non-local is we need to type. I'm not sure right now for this code, but I think this we need to do. Now node is, let's say, 0. We initially it will be 0 to basically 0 1 2, in total 3. It is first node is 0, second node is 1, and third node is 2. Okay, now we are going to explore. When we are going to explore, if that is not visited, right? If that is not visited, means that will be part of new province, so province count will be increasing, and we'll be solving that with DFS. Now within DFS you need to first mark this, that particular node is true. Now for each adjacent node, now how to get adjacent node number? You can do one thing. Instead of doing this, you can start adjacent node in range of, there will be n elements only, right? So you need to just do this. You need to start from 0, whether 0 is adjacent to particular node or not. How you are going to check? Visited of that adjacent node is false, and is connected of that particular node is ad- that particular node value. Now we are in row. The column value of that adjacent node is equal to 1 or not. If it is equal, then we are going to explore this, else we are not going to explore. So yeah, that is, I guess, pretty much about the code. Yeah, let me run it once. Yes, this is what we actually wanted. Let me submit it, and then we'll check what will be the time complexity and all. Okay, so if you see that code got passed, let's come to description and see here means, if you see at each time, means, if you see this particular graph, and in this graph, if you analyze, we are just what color is not used right now? Brown is used, blue is used, green is used, white is not used. Yeah, so if you see here, the first time we are going to explore 0th index. That is just one event, right? Means one time only. Next time we are going to explore this, that is first time we are going to visit. Now if you see, you'll come to 3, that will be first visit. Now you'll be coming to 2, that will be first visit. And when you go back and check that, that you can't do because that is already visited, means that you are not going to do. Actually you can do, but you are not going to do that. So if you see, each time it got explored one time. And next you check for 3, means you check for node 2 first, so it will be checked twice, and it will be checked twice, 3 will be checked twice. Means yeah, means if you see, at any node you are just exploring that node once only. It means you can see whatever the complexity of node you are for each node, what you are doing for node, you are going to run your algorithm, right? Here if you see, in this for loop, for each node you will be doing something, right? So for that node, how many or what operation you are performing, for that node you are just exploring their adjacent nodes, right? If you see, for this particular node 0, you explored all 4 values, that is of order n for 0th node, right? What next? If you see, for the first node you'll be exploring this much, and jumping over third you'll be exploring this much, and jumping over second you'll be exploring this much. Means if you see, you explored n minus 1 times, means n minus 1 times what you explored, means you performed operation order of n, n minus 1 time, and 1 time order of n. So if you see, this actually boils down to n times of order of n operation you performed. So that's why its complexity will be order of n square. And yeah, as it is matrix, anyway you are going to explore all the values here, right? So that's why as well the time complexity of this algorithm is n square. And if you see space complexity, then what will be the space complexity? If you see space complexity, we have used a visited array of size n. Other than that, all these are just a variable, right? Means this is a count, and what else? Nothing, right? So we used space of order of space complexity is equal to order of n. So this one is your TC, this one is your SC. Yeah, that's it for this video. We'll explore some other problem in next video. Yeah, thank you so much. Bye.